in our last lecture, what we have done is we have studied how to represent the velocity time graph and displacement time graph, right? We have already done the three equations of motion. So today we are going to derive the same equations of motions through graphical method. See, there are three types of method by which you can derive these equations. One is that the simple derivation using the definition which we have done. Second one is graphical method, and the third one is differential method. So today we are going to cover the last two methods. First of all, this one is graphical method. Alright. Now, what we have learned till now is, in velocity time graph, this is how you represent a velocity time graph. Here velocity is in meter per second and time in seconds. Suppose an object starts with initial velocity this u, that is at time t equal to 0, initial velocity is u, and it has reached a velocity of v at time t seconds, right? So velocity is v, initial velocity was u. So how would I depict it, this thing in the graph? At t equal to 0, this will be the mark. At t equal to 0, it has initial velocity, and at time equal to t, it has the final velocity v. So this will be the mark. So this is how your graph would be. Suppose an object moves further with different velocity. So this time, if it is moving further with different velocity, here, from here to here, like from this point to this point, what is constant? Acceleration is constant, velocity is not. So object cannot move with different velocity because at every point it is moving with different velocity already. So the thing constant till this point to this point is constant acceleration, which is gained by slope. For example, if the object now moves with a different acceleration, the slope could be like this or this or this. It depends on how the object is moving. This kind of slope you will get when object is at rest, right? No, this kind of graph you will get when object is moving with that constant velocity, not at rest. This means the acceleration is 0. Here it has less acceleration, here it has very high acceleration. So velocity time graph, the slope actually gives you the acceleration, right? So this is what we are going to use while deriving the formula. I want the acceleration. Acceleration is given by slope which is tan theta. So slope of this line from here to here. So slope which is equal to tan theta will be equal to height over base, right? Or if I write it like this, ABC, it will be BC upon AC, right? What is BC? From here to here, it is complete final V, and from this point to this point, it is U. So what is this one BC? BC would be V minus U over AC. AC is the time interval T. So this is acceleration. If you cross multiply, AT is equal to V minus U. I am taking U that side. So this gives me V is equal to U plus AT. This is your first equation of motion. Second equation was, I want to find out the total distance covered, S, which is by graphical format given by the total area under the curve. So I need to find area under the curve. So area of graph, which is the total graph basically. So here we have this total area. I think we should write T here, right? This is T. This area plus this area, right? This will give me the total area under this slope up to which the object is moving, because this is only the graph we are left with, right? So this is area rectangle plus, I can easily write it like this, area figure 1 plus area figure 2. That is the simplest way of representing, but I write rather in this format, area rectangle plus area triangle, right? What is area of this rectangle? The area of this rectangle would be this length into breadth. The length is T, breadth is this height, which is U. So UT plus area of rectangle. What is area of this rectangle? This is half into base, this is base into height. So base is basically this T, half, base is T into this height. Height is BC, which is V minus U again, V minus U. from first equation we know that v minus u is equal to at. So here I can write at. So we are left with ut plus half t multiplied by at. So this is giving me at square, right? So that is how we have find our second equation of motion, half at square. And if I substitute the value of t or a from this equation into this will lead you to the third equation of motion. So this is how you have to derive equations of motion.